This is AP Calculus Self-Check 8.3 Solutions. This first problem came from the 2010 question number 1. So we're talking about the snow problem just like we had from the homework. So we're talking about how many cubic feet have accumulated. So we're not talking about the negative and positive rate because it's accumulating with this positive rate here. This is the positive rate right down here. And this is all of the negative rate. And depending on the interval that we're talking about, the negative rate will change. So accumulation, we're just talking about this function right here. So what we need to do is we need to do the integral between 0 and this number 6, between 0 and 6 of our f of t. So I'm just going to write f of t here. F of t dt. And, well, I guess it's how much snow have accumulated, or how many feet of snow have accumulated. We really are subtracting this 0. So it's, I guess if I was being technical, it would be f of t minus the rate, which is g of t, which is going to be 0. I was going to leave it out, but I'll leave it in. So dt. And what is that going to equal? So when I do this on my calculator, let's pull that up. So again, I need to go to y equals, I need to do 7 times x times e second natural log e to the power of cosine t, and all of those parentheses, sure. All right, so when I do the integral between 0 and 6, math 9, integral of y1, and that's going to be minus 0, so we don't really need to do anything. That's going to be with respect to x between 0 and 6. And what do we get? 142.275. So
I never get ones right on this.
142.275. Don't forget your units. What are we talking about here?
Cubed.
Feet cubed. Yep. Thank you.
Mr. Sindel, will you go back to telling us what each point is on it? So I know, like, if I miss putting something on.
Sure. Yeah. So you get 1 point for the integral. So if you have the integral set up, you can either just put f of t. You can put just 7t e cosine t. We can put this, and you get 1 point if you got the answer correct. You can do this 0.275 or 0.274 if you truncated, if you didn't round. So there's 2 points there. For part B.
And unit of feet squared, okay.
Yeah, you have to have feet squared, all of that.
Feet squared again.
Or feet cubed, because it says cubic feet right here. All right, so for part B, find the rate of change of the volume. So we're dealing with rate, which means we don't have to do any integral. We're just taking f of that number minus g of that number. We're doing the positive rate minus negative rate, so it's going to be f of 8, and we're going to subtract the g of 8. We're subtracting positive rate minus negative rate.
I'm literally a moron. No, I knew it was positive rate minus negative rate, and I switched them.
So that's going to be approximately some number. I guess this one was also approximately. I should have been more exact. You're not going to lose a... Oh, that's not what I want to do. You're not going to lose points if you don't do this, but I like to be very specific in my math. This is approximately equal to this. This one is going to be approximately equal to... I don't know what this function is, so I'm going to go to the... Oh, no. Stop. Second off. Clear. So...
You said clear instead of clear.
I need to go zoom 0. Oh, shoot, my window isn't even set. Okay, sorry, I had to set my window. My window should be between 0 and 9. 0 to 9. And now, zoom 0. Alright, now that it's graphing it correctly, what I'm going to do is I'm going to trace for the f function. That way I can find where f of 8 actually is. So if I click trace and I click 8, so my value is 48.417, so this is going to be 48.417, and then I'm going to subtract g of 8. G of 8 falls in between this interval, 108.
Wait, that was trace value, right? Like find the value?
I think you just, do trace.
Yeah, trace, and then I hit 8 to find the value.
Oh wait, I'll let you finish, sorry.
And again, that is approximately equal to, I got negative 59.583.
Just kidding, I did it right. Nice.
5.8. Oh, come on now.
I just wrote it.
5.8.
Mr. Sennell, how
3.
do you know you weren't supposed to do the integral?
Because when it says find the rate, the thing that it gave us was the rate.
Oh, so you don't need to change anything.
So you don't need to change anything, exactly. If it was asking for feet or change in feet, then I know that it's not asking for a rate anymore.
Okay.
Yeah, and to find this on the calculator, you can immediately just hit minus, according to the girls, 108, and you'll get... You can't do that, not on this calculator at least. So if I do minus 108, it'll also pop up here. No, it won't. That's interesting. So how do you get this y value? I guess you just have to enter that y value in.
On the other one, it gives you just one answer. On this one, it gives you both.
Okay. There's actually a way to do that, but I don't think it's very valuable. Just re-enter it and then go for it.
I noticed.
All right, part C. This thing is, hard, for lack of a better word.
Great. So then I did it wrong because I found it quick. I didn't even start.
All right, so this is how I'm going to set it up. I'm going to do a table. T, that's going to be start plus change.
Wow, great. Didn't do that.
That's going to equal, instead of the n, it's really going to equal a function. So it's a slight modification. So for t, it's going to be piecewise defined because what we really want to say is not start plus change, but we want to do, for the change, it's going to be positive rate minus negative rate. So for that first time, for in between these intervals, between 0 and 6, so between 0 is less than or equal to t is less than 6, the start, did it give us an initial condition?
0? No, it's 0 at midnight.
0 at midnight. Perfect. That's what we need. And where does it say that in here?
At the very top. There's no snow.
Oh, no snow. Yeah, perfect. So my start for this one is going to be 0.
Sorry.
My change here is going to be the integral from 0 to 6, not 0 to 6, 0 to t, because we're having a function here. Whenever it asks for a function, you're going to have the integral from something to t.
Really?
Yes.
This is so confusing.
This is using the fundamental theorem of calculus, which basically says you have to have a number to t of something else. And what are we going to have here? We're going to have 0, yeah. Because it's just talking about Janet. We're not talking about this f of t at all. It's always this g of t. So integral of 0 dt.
So we're not doing positive rate minus negative rate. We're just doing negative rate because it's only about Janet removing the snow.
Yeah. So when I evaluate that, this is going to be t minus 0 times 0, which is really equal to 0. So our function is 0.
You always have to do gt in there, and it's that one 0. So.
Yeah.
But why are you multiplying it again?
So whenever you have a constant function, our trick is you do this minus this times this. So t minus 0 times 0. So our function is going to be 0. All right. So now we're going to use our how much we've accumulated in our next answer. This is, it's a little bit tricky here. So from 6, I think it goes from 6 to 7, right?
Yeah.
6 less than t is less than 7. Our start, now we accumulated 0. So again, it's going to be 0. But it's not the same exact 0 because our start down here is going to be not 0. We want to go for now from the integral between 6 and t. It's a different amount.
So
And
how come we don't know the t?
we do know, we don't know the t because we need a variable. Remember, it's asking for express this as a function. We need a t in there for a function.
But you know it's between 6 and 7.
But what if they ask for like 6.5 or something?
Exactly, yeah. We're trying to find a function that evaluates to every single possible time. So if we did a number here, then it would be just a constant number. If it's t, now it's a function.
Have we done one like this before where it's an integral, not a time that you're trying to find?
We've found something similar to this where we had the antiderivative using the fundamental theorem of calculus.
The part that's confusing me is how it ends up as a function, not as a amount of snow.
Yeah, and we have done that in the notes, but we haven't applied it to a problem. This is applying it to a problem. All right, so the change here between 6 and 7, she's shoveling 125. So this is going to be integral of 125 dt. And again, that's going to be t minus 6, because again, you just do the bounds subtract each other. T minus 6, and that's going to be times 125. And I could simplify that a little bit if I wanted to. It's 125t minus, oh god, what is that going to be, 450 or something like that?
But on the because
Yeah, just leave it like that. We're fine. Okay, and then from 7 is less than t is less than 9. Okay.
That's our starting position.
So that is our starting position is at 7. So now I need to plug in 7 in here. So when I do 7 minus 6, that's 1. 1 times 125. Our starting position here is 125. That's the difficult part here. That was probably the trickiest part on this part C. So noting that the initial condition for this one was 125, the integral from 7 to t of, and what is our function now? It's 108 dt, and that is going to be 125 plus t minus 7.
Wait, I think it's 108 now.
100 what?
108.
Oh yeah, it is. I don't know what I'm writing here. Get rid of that. It is 108. I copied that down wrong. T minus 7 times 108. I was about to do it again. 108. And there you have our functions. So this is the function 0 for this time interval. This is the function for this time interval. This is the function for this time interval. And it just comes from applying the fundamental theorem of calculus. So how to score this thing? Do we even score B? Oh, sorry about that. B, that's just 1 point. If you got this number, give yourself 1 point. For C, how many points do you get? There are 3 points to get. And if you got the function for there, give yourself 1 point. Function for here, give yourself 1 point. Function for here. So if you got all 3 functions, you got 3 points. If you got one of the functions, you got 1 point.
That was really hard. Like, I don't think I would ever get that, ever.
But now you might, right?
I just want, okay. Thank you. It's easier to grade when I know I have 0 points.
All right. And then for part D, let's go down to blue. How many cubic feet of snow are on the driveway at 9 a.m.? So again, this is kind of like plugging in the initial condition if I were to go from 9 to something else. So I need to plug in 9 into this equation. So when I do that, it's going to be 125 plus, and then it's going to be 2 times 108. The 2 coming from 9 minus 7 here. So 2 times 108 is 116. 116 plus 25 is 141. Is that right? No, that's not right. Hold on.
I did the integral 0 to 9 f of t dt.
Yeah, okay. It's because it's how many cubic. I was just doing. Yeah, I'm totally wrong. Sorry. What this was calculating is how much Janet is shoveling. This is a totally different problem. We have to do the positive rate minus the negative rate. You're right. So this is going to be.
Can I get a point? I just crossed out.
Sure, you can get a point for that. 0 to 9 of. We need f of t.
Cross all that out?
Yeah, sorry about that. I was still thinking in part C.
Basically, this is like part A, right? Except that now we actually have a negative rate.
Yes, I guess that is a good way of saying it.
Yeah, like now we have something to subtract.
So the quickest way to write this is you actually subtract h of 9 because we know what h of 9 is from this function up here. H of 9, remember all of this? I guess I should have wrote h is equal, h of t
F of 9 as well?
is equal to, you have to be careful because f of 9 represents a rate.
And how do you know it's h of 9? Oh,
I think it gives it, yeah.
So this is telling you how much snow she has removed with this function right here. H of 9 is already in units of snow. We don't have to take the integral of h of 9. We could have done the integral of of g of 9, but to get to that, we would have had to do all of this math again. So I'm just writing h of 9 here.
So I did do all the math again.
That you'll still get the right answer. It just took you longer probably.
Don't take integral because it's already in units of snow.
Yeah, h of t is already in units of snow. This, if I plugged in 9 into this function, I would have got how much snow Janet has removed. But how much snow has accumulated? We haven't done that yet. So in order to do that, I need to go to my calculator. And I can just do it on here. I can do second trace 7 from 0 to 9. And it will do that for me. please. There it goes. Okay.
So wait, we're not supposed to take the integral of...
You can do the integral of g of t, but I did it quicker by just taking h of 9. So this is going to be equal to, so I have 367.335. And I'm going to subtract however much snow Janet has removed. And since I have a function from part C, I'm just going to do that. So this is going to be, the function from part C says I do 125 plus 2 times 108. And 2 times 108 is 216, 341 right here. So this is 341, I believe. Maybe I should just use my calculator since I have it. I did not get enough sleep, so.
It is 341.
Thank you. So what I can do is I can use my answer, and then I can subtract 341.
Mr. Snow.
Yes.
I don't know what I did. So I took the integral of g of t, but I got 972.
Oh, really?
Yeah.
Check your function.
I'm pretty sure it's right.
7x e to the cosine x.
Or no, it's or yeah, that one was right. I got that one.
Oh.
But then for the g of t, the next one,
This one?
yeah, I got 972. So could you show us if you did take the integral of g of t?
Yeah, because I think I did that wrong too.
All right, so let's see if I can change gears here. So if you did the integral of g of t, this graph would essentially look like this. So between 0 and 6, so I'm going to say 6 is there, your line is nothing. There's no area. And then all of a sudden it jumps all the way up to 125 between 6 and 7, so that bar is probably really slow. Maybe I should just go like this. 6 and 7, there it is. It's at 125, 125. And then all of a sudden from 7 to 9, that bar jumps down a little bit lower right here. So you're really just finding the area under here. So between 6 and 7, that's a distance of 1 here and 125, so that's 125 for the area here. Between 7 and 9, that's 2 times 108. So again, this level right here is 108. And 2 times 108 is 216. 216 plus 125 gives you 341.
So what I did is I did from 0 to 9, not from 7 to 9.
Yeah.
So that like gave me the yeah.
In fact, I actually prefer this graph over just plugging it into this because I don't really have an understanding of what's going on here, but I definitely understand the 341. And even the 125 plus 2 times 108, that is visually demonstrated by what's happening on this graph.
Wait, am I just like crazy? But like if I'm taking the integral from like, just like assume I'm taking the integral from 0 to 9 of 108, can I just do 108 times 9?
No, because 108 times 9 assumes that you've been shoveling snow for 9 hours at a rate of 108.
So like if the whole thing, if it was 0, if that like integral was 0 to 9 and then it was 108, that's what you do. And since it's only from 7 to 9.
Oh, then it's that. So then.
Yeah, your graph would have looked like this, Kaylin, which is very different from this graph.
So then how did, so you only found it from.
So I graphed 0 between 0 and 6, and then I graphed 125, which is just a straight line from 6 to 7. I graphed 108 between 7 and 9, and then I found the area underneath. All right, and then finally how to score yourself really quickly. So there's 3 points to get here. If you said anything about the integral from 0 to 9 of f of t, give yourself 1 point.
Yay! I get 1 point on this problem.
If you used h of 9 or some other method, if you said you need to somehow do the integral of g of t between 0 and 9, or if you need to use h of 9, give yourself 1 point. And if you got the answer 26.335, give yourself another 1 point. And this was out of 9 points. Okay, and on to self-check 8.4. So water is going into a tank, analyzing positive versus negative rate. So positive rate is this one, positive rate, and the negative rate is this one, negative rate. All right, and it tells us that They intersect here at 1.617, so perfect. We don't even need to do math.
Why did I not pay attention?
Bro.
I calculated those
I
myself.
did too. But I got it right
Me
though.
too.
I'm so
I
proud.
076.
Oh my god.
Awesome. So that it represents those two intersection
That
points.
was so
Stupid.
good.
I wasted a lot of time.
So on the graph, this curvy line is the positive rate. That negative line is the negative rate. Also important to know. So when I talk about part A, how many gallons of water enter the tank, it doesn't even ask about how much it's changing. So we're just talking purely about that positive rate. So entering the tank, that's going to be integral between 0 and 7 of that positive rate, which I think is f of t dt.
Yeah.
Okay, and that's going to be approximately, and to the nearest gallon. It tells us how to round it.
Oh, so you don't have to put the negative rate in there?
You do not need to put the negative rate because it's just asking about how much is being added. So my function is 100, this thing squared, sine of square root of that, and second quit. Okay, so now I need to do the integral between 0 and 7, right? 0 and 7, yep. So math 9 of y1 between 0 and 7.
If we don't round to the nearest gallon, is that a point off?
It is, yep.
Oh.
You have to read instructions.
I was so bad at reading instructions.
So 8 point, or what am I doing? Not 8 point, 8,264, because I'm rounding up. And that's in gallons. Have the correct unit here. All right, part B. This is moving too far over.
How many
So,
points is that up to?
so this one is 2 points. You have to have the integral in the answer. So if you have the integral
No, wait.
and then
no.
you have the answer, 1 point each.
So I was like, I know I did it right, but I had a different answer, and it's because I put in my equation wrong.
That is unfortunate.
Which means everything from here on out is wrong.
Yeah, gotta double check that.
I just put, instead of putting t, I put 7.
That's
All right.
like my worst fear.
So now I need to find intervals which the amount of water is decreasing. Okay, so this one is really just looking at the graph that they gave us. So decreasing is wherever the negative has a higher height than the positive. So you can say that in this interval here, it looks like it's decreasing because this negative rate is higher than the positive rate. And where else is the negative higher? Oh, so in this interval right here, the negative rate is higher than the positive rate. Both of those will have a total negative rate. So, and that's just judging by the graph. So make sure we have some sort of explanation when we're doing that as well. So what is the first interval? First interval is between, so we'll say decreasing. Decreasing from, if you don't like alligators, as Carly calls them, you can just go like this, between 0 and 1.1 or 1.617, I believe. And the other interval, just looking back at our graph, was 3 to 5.076, 3 to 5.076. If I was being really specific about this, I would have this thing be not a square bracket, and I would also make it so that this thing was not a square bracket, it would be a parenthesis. If I was being super specific, because at 1.617, it's neither decreasing nor increasing, and give a reason. And the reason here is because we just need to say that the height was greater. So, and then the way that we say height in this graph is just f of t. So the way that we say that is that f of t, that positive is not as big as, it is less than the g of t. Or vice versa, the g of t is greater than the f of t. So that's the perfect reason. Nice, short, concise. So how to score this thing? 2 points. If you have both these intervals correct, give yourself +1 if both of those are correct. And if you have the reason, give yourself another +1.
I am so proud of myself for getting the intervals, but like, that was dumb of me to forget the reason.
All right. And for part C, so when is the amount of water in the tank the greatest? And then to the nearest gallon, and find the time and justify. Justify will come from the chart. So we need a t, we need a start, we need a plus the change, and that will give us the end. All right, so t. So we have a lot of points, right? We have 0, 1.617, 3, 5.076, and 7. There's a lot of things to calculate here, but let's be smart about this.
I forgot about 3 as well.
Wait, why is 3 1?
Because there's a discontinuity.
Frickin' endpoint or whatever.
Yeah, discontinuity is a CV.
I hate CV.
So if we're smart about this, we'll say, do we really need to include 1.617?
Yes.
We don't really need to. The reason for that is because we're looking for the greatest. If it's the greatest, then it doesn't make sense to have this negative. We know that this entire red spot is negative. So it can really only be the greatest.
About that, Mr. Sindel.
It can only be the greatest at 0, 3, or 7. It can't be at 5.076 because I just had a bunch of negative stuff taken out. I have a lot of water taken out. It can't be at 1.617 because I just had all this stuff taken out. So logically, it should only be at 0, 3, or 7. So let's simplify our chart to say
The only ones I didn't include was 3. So
0, 3, and 7. All right, so the start. The start for all of these is 5,000.
Wait, so discontinuity is also a CV?
Yes.
Why don't you include 5.078?
So the reason that we don't include 5.076 is because if we look at that point, we just had a ton of water. All this red is water being taken out. That's obviously not going to be the greatest if we just ended by taking out a ton of water. It can only be the greatest where you end by adding water. We added water between 1.617 and 3, so it's probably here at 3 maybe at 7, maybe at 0. All right, I have exactly 50 seconds. Let's see how fast I can do this. So I need to do the integral between 0 and 0 of, it doesn't really matter because it's 0 to 0, and the end is going to be 5,000. And I need to do the integral between 0 and 3 of the actual function, so f of t minus g of t. And I need to do plus integral between 0 and 7 of f of t minus g of t. And how to do those, so on my calculator, let's do this. So it's going to be math 9, and it's going to be vars, right? Enter, enter. It's going to be y1 with respect to x from 0 to 3. And
Wait, what about the G?
so I'll get the g of t. G of t is a constant function, right? So g of t, we said g of t is 250 in that interval. So it's going to be 250 times how much time happened. So this is going to be equal to 5,000, the initial condition, plus 876.59 minus, and then 3 times whatever, 3 times, what was the rate again? 3 times 250.
Wait, why did you get 3 times?
Because it's 3 minus 0.
Oh.
And just stick around for another few minutes, 5,000 plus, and then between 0 and 7, so I do second enter, and I change this 3 to a 7, and I hit enter, 5,000 plus. Come on, calculator, you got this. Oh my god, that's so much. 8,263.81. It's to the nearest gallon, so it doesn't really need to be rounded that much. Minus 7 times 250. If I simplify all of these, I'll get about 5,127. And if I round this one, it's going to be 4,514. All right, so the final answer is the greatest is obviously at it actually was at 3. So not only do you have to say that that was the greatest, so greatest is 5,127 gallons. Gallons. And you have to say the time too. At time equals 3, and is it in hours? 3, yeah, 3 hours.